In this class, we will be discussing problem solving using free body diagram. Let's discuss the subject. So before that, I am going to draw a diagram. So I have a wall and I have three strings. Let's take this to be string A, this to be string B, and it is making an angle 37 degrees. Then I'll take another string C and a block of mass M is equal to 60 kgs is hanging to this point. Let's take this as point C, this as point A, and this as point B. So what are we trying to do? We are trying to solve a problem using free body diagram. So let's get into the concept and let us consider this point to be O. Okay. So what is free body diagram? In free body diagram, what we do is we take a object individually and we look at the forces acting on it. From this diagram, it's very clear that this body is in equilibrium. That is, there is no acceleration to any of the objects present in this diagram. So what are the steps we follow for calculating or solving a problem using free body diagram? So what do we do? So here step 1 is draw the free body diagram of the objects that we are going to analyze. So what we are to try to do is that we have three strings. So we have to calculate the tensions in each string. So in the previous class, I have said you that tension always acts away from a point. For example, let us take this point O. So if I am asked to find out the tension acting on the string A with respect to O, what do? I say that the tension will be acting in a direction that is away from the point. The same way, if I am asked what is the tension acting in string B with respect to point O, I will say that the tension is acting away from point O. The same way, what is the tension acting within string C with respect to O? I say that it is moving away. That is, I will write it as tension TC. Okay, so we have TA, TB, TC. The same way, if I am asked what is the tension acting on point A, I will say that in the string A, I'll say this EA. The same way, what is the tension acting at point B in string B? I'll say it is moving away. So you call it as like this. This is TB. In the same way, I can write it as TC. So you can see that whenever I am asked to find the tension at a point O or A, it always moves away from the point. That is, the tension, the direction of the tension is always written in such a way that it is moving away. When I pull a string, see, I take a string, I take a rope, I connect it to a point, I pull it, what happens? The direction of the force is towards me, that is away from the point. So tension is a pulling force. Okay, so you can clearly see it is moving away. So what I have to calculate in this? I have to calculate the tension TA, TB and TC using free body diagram. So what is the step 1? Draw the free body diagram of the objects that we are going to analyze. So you can see that this particular object is in equilibrium. Why is it in equilibrium? Because there is no acceleration to any of the objects. So the step 1 is analyze the free body diagram. Now let us analyze the free body diagram of point C. Let us take point C. See, when I take free body diagram of point C, so this is point C. Now you can see that what is the force acting here? The gravitational force. Let us assume G approximately equal to 10 meters per second. So what will be the force acting in this direction? That is F is equal to mg, that is equal to 60 into 10, that is equal to 600 Newton. See, generally G is equal to 9.8 meters per second square, but I am taking G is equal to 10 meters per second square for the convenience of calculation. So what do we have here? TC. See, so one force is going in this direction. What is TC here? TC is equal to, you can clearly see it is 600 newtons. Okay, this is the first step. What is the second step? Second step will go to that. So let's take the third step. Third step and the fourth step will go to that. So first thing is free body diagram of point C. I call it as TC is equal to 600 newtons. Now what is the step 2? Step 2 is, okay, step 2 is to find out the coordinate axis. Now this is very important to establish coordinate axes. So this is very important because you see, when you have a string making an angle 37, so it's always convenient to draw the axis. So let this be y-axis, this be x-axis. Now you can see from this diagram, this angle will be equal to this angle. So this will be 37 degrees. Why this is 37 degrees? Because they are alternate angles. The same way, this is, if I draw a axis here, it is 53 degrees, and here this will be 53 degrees. Why is it 53 degrees? Because they are alternate angles. Okay. Now let's go further. Step 2 is draw the coordinate axis or establish the coordinate axis for our convenience. So we have done that. Establish the coordinate axis. Okay. Step 3 is write down the components of force. Okay, this is very important. In this case, we can see it is a straight line. It is in the same coordinate axis. Here it is very important. Write down the components of force. It's very important. Let's get into that concept. So let's take the free body diagram of point. So we have done with this. Now let's go to the step 2, free body diagram of point O. Free body diagram of point O. So this is very important. Let's get into this. So we know that from the diagram it is equilibrium. The forces are equilibrium. So we can come to know that from this at point O, the forces acting in the x coordinates are equal. That is, sum of the forces acting is equal to 0. Now you may ask me, why did I directly write TC is equal to 600 newtons? You see, at point C, the only forces acting are in the y direction. There are no x direction. So I just ignored it and I directly wrote it as TC is equal to 600 newtons. In this case, there are two axes that is coming into play. That is, one is x-axis and one is y-axis. So what am I doing? I'm finding out the sum of the forces. I'm writing that sum of the forces is equal to 0. Why am I writing sum of the forces is equal to 0? Because this system is in equilibrium. When the system is in equilibrium, all the forces acting in the x-axis and y-axis are equal to 0. So let us see what are the forces acting in O in the x coordinates. So you can write this as PA is equal to, now this is very important. Listen carefully. Now this is O. Now you can see a PA is going in this direction. See, generally, if this point has to be in equilibrium, that is, sum of the forces in the x direction should be equal to 0. That is, a force acting in this direction, that is PA, must be equal to the force acting in the x direction. Now my question is, what is the force? What is the force acting in the x direction? Now this is very important. Now you can see that the string B is in a particular angle 37 degrees with the x-axis. Okay, so you can see that the string B makes an angle 37 degrees with the x-axis. Now my question is, what is the force? What is the force? What is the tension acting in the x-axis? The direction of the tension B is, you can see the direction is it's making an angle 37 with the horizontal axis. So my question is, what is the force acting in what component of force of tension B, or what part of tension B is acting in the x-axis? And that is very simple. When I draw a component, you can see it would be TB cos you can write as TB cos 37 degrees. Now you may think, why am I writing cos 37 degrees? Because you see, this is a right angle triangle. This is tension B, and what is the component of tension B onto the x-axis? It makes an angle 37 degrees. So you can write it as TB cos 37 degrees. The same way, let's take this. It makes an angle 53 degrees. That is, sum of Fy is equal to 0. Sum of the forces acting in the y direction is 0. So you can write it as Fy is one force is acting in the negative y direction. That is, let us take it as Tc. It is actually 600. We have already found out. Now what is the opposite force acting onto it? From here you can see this is acting in the y direction. That is Tb cos 53. Why cos 53? Let's take this is a right angle triangle. So when you draw a component of B onto the y-axis, what do you get? Tb cos 53. Tb cos 53 degrees. Now you have got the equations. So what is step 4? Step 4 is solve the equations. When we solve the equations, we will get the result. Now we know that sine 37 is equal to 3 by 5, and similarly cos 53 degrees is equal to 3 by 5, and cos 37 degrees is equal to 4 by 5, and sine 53 degrees is equal to 4 by 5. I would suggest you to remember this because we will be using these 35, 37 even in the examination. You get these angles because it's very easy for us to solve the problem. So let's substitute these equations. There TA is what? Let's calculate TA is equal to TB. We have to find out TB into what is cos 37? Cos 37 is 4 by 5. And what do we have the other one? TC, we already know. TC is equal to 600 is equal to TB is what? We have to find out TB into cos 53 is what? Cos 53 is 3 by 5. Now how do I calculate? 600 into 5 by 3 is equal to TB. So what do I get? 200. So TB is equal to 1000 newtons. The same way, what is TA? TA is equal to 1000 into 4 by 5. So what do I get? 5 cancel. So 5000 you can divide, it's 200. So what do I get? This is equal to 800 newtons. So what is the final answer? You get this as TA is equal to 800 newtons, TB is equal to 1000 newtons, and TC is equal to 600 newtons. I hope you got an idea how to solve this problem. It's very simple. The coming classes we will be discussing this problem.